Let's go ahead and complete this table, and then we'll graph the function. Lastly, we'll identify the constant ratio and the y-intercept. Just a quick review from yesterday. We learned that the exponential function can be represented by this basic form, y equals a times b to the x power. And you can use the exponential regression, a times b to the x1 power, to help you figure out the equation of any exponential function if you have a table. And then another thing you need to know is that your a value is going to be your y-intercept. And you need to know that your b value is going to be your constant ratio. So that's just review. We went over that in the video that we watched yesterday. Okay. So we'll use that in order to do number one. We need to complete each table and graph the function, then identify the constant ratio and y-intercept. So we'll go ahead and substitute in each of these x values. So 2 to the x power, I'm going to substitute in the -2. And if I were to evaluate that, I would use my rules for negative exponents. This is going to be the same as 1 over 2 to the second power, which is 1 to the 4th. Or sorry, 1 over 4. And then my next one, if I were to substitute in -1, that's the same as 1 over 2 to the first, and I can simplify that to get 1/2. Substituting in a 0 for x, 2 to the 0 power is just 1. Remember, any number to the 0 power is 1. And then if I substitute in a 1 here, 2 to the first power is just 2. 2 to the second power would be 4. And then we can go ahead and graph. If I go over to the -2, up to a 4th, over to the -1, I'll go up to the 1/2. 0, I go up to the 1, over 1, up to the 2, and then over 2, up to the 4. This is what my graph would look like if I were to graph the function that's represented in the table. In this case, your function was given to you, f of x equals 2 to the x power. But remember, if you have a table, you can find the function using the exponential regression. So I just want to remind you that from yesterday. So I'm going to show you on Desmos that I could find my function by entering the table. That'd be 1/4, 1/2. And that's what it would look like. I can use my exponential regression to find my a and b values. So you can see my a value is 1. That's my y-intercept. My b value is my constant ratio, which is 2. And this is what my graph would look like. And you can also see that that looks a lot like the graph that we made. So our a value is 1, that's our y-intercept, and our b value is 2, which is our constant ratio. All right, I'm going to do now number 3. We'll substitute in -2. 1/3 to the -2 power is the same as using my rules for negative exponents. I'm going to take the reciprocal of my base, so that'd be 3 over 1, and then my exponent becomes positive. So we now have 9. I can substitute in the -1, take the reciprocal of the base, and then your exponent becomes positive. 1/3 to the 0 power is just 1. 1/3 to the first power is just a third. And then 1/3 to the second power, that's 1/3 times 1/3, which is 1/9. And then we can graph this, go over to the left, up left 2, up 9, left 1, up 3, 0, up 1. Over 1, you're going up a third, and then over 2, you're going up a ninth. That's what it would look like if we were to graph it. I'm just going to show you again on Desmos what this would look like if you were to only have the table and you needed to come up with this function. Sometimes you're asked to find the function given the table. So let's do that. Our values are 9, 3, 1, 1/3, and 1/9. And that's, whoops. So it looks like ours, but let's put on our linear or exponential regression. And you can see it matches the graph that we came up with. And then our A value is 1, and our B value is being expressed as a decimal, which is 0.33. It's the same as 1/3. If you aren't sure about how to get the fraction, you can just do one term divided by the term before it. So 3 divided by 9, that would give you your 1/3. And that's going to be your constant ratio. Your B value is your constant ratio. So my A value was 1. I could see that right here. My A value is 1. My B value, it's on the calculator, it's giving me the decimal equivalent. But if you notice, if I take the second term and divide by the first term, that gives me my 1/3, which is the same as 0.333, but it's also the same as what's expressed in my original function. All right, let's do this scenario that we have on the back. It says, as part of a project in health, Aaliyah, Kim, and Reese are raising awareness and challenging others to eat healthy in the morning. Today, they sent selfies to themselves eating a healthy breakfast to 4 friends and challenged them to do the same the next day. This next day, when others send selfies of themselves eating a healthy breakfast, will be considered day 1 of their results. The following day, only those contacted the previous day will send selfies to 4 friends. The challenge will continue to spread. Assume everyone contacted completes the challenge and new participants are contacted each day. So what we're supposed to do is write an exponential function to represent the number of new participants of the challenge as a function of the day number x. So first let's look at our table. So on day 1, there were 12 participants. Day 2, there were 48. Day 3, 192. And day 4, 768. So let's go ahead and use Desmos. We're going to enter the table. And then we're going to use our exponential regression. And we're looking for our A value and our B value in order to get our function. So let's go ahead and enter those values in. And I can see that My y-intercept is 3. That's what I'm starting with. And my constant ratio is going to be 4, multiplying by 4 each time. So I'd have y is equal to 3 times 4 to the x power. I'm just substituting in my y-intercept, my a value, and my constant ratio, which is 4. And you can see by looking at your table that we are multiplying by 4. So if that were the case, if we were multiplying by 4, we would have to start with 3 people. So that's going to be my y-intercept. And then we're going to sketch a graph of the scenario. So if we were graphing the scenario, our x-axis is going to be time, and our y-axis is going to be people or participants. And then we can say that we're starting with 3 people. It's going to be kind of an estimate down here since our scale goes from 0 all the way to 100. When I have day 1, that's 12 people. Still an estimate of where that point is. Day 2, we're at 48 people, which is almost halfway up here. Day 3, we're at 192 people. So almost 200, so you're about right there. Then day 4, you're at 768. So you can see our constant ratio in this case is 4, and our y-intercept was 3. We started with 3 people.